This is lesson 2.7 out of the Introduction to Algebra book. We are on page 74. This will be one-page notes. And lesson 2.7 is titled, I'm going to write real small here, try, Using Distributive Property. We learned that in lesson 2.6. Using distributive property with variables. Now we're getting into the letters and numbers all mixed up. We'll be doing some combining like terms. If you don't remember how to do that, look back earlier in this block. All right, warm up for lesson 2.7 is number 1. Let's see if we remember how to do our distributive property from 2.6. 5 times 6 plus 8. Number 2. 8 times 12 minus 9. Skip 2 blanks and then 2 lines, and then number 3. 3 times 20 plus 4. And number 4, 6 times 3 minus 4. All right, those are your warm-ups. And then skip 2 blank lines here again so you got room to do your work. And we'll put in our I can statement. I can simplify expressions with variables. When we're done with this lesson, you'll be able to use the distributive property while simplifying expressions with variables. All right, my dark green pencil, and we get down to the work. All right, so we have just, I'll make sure you can see that okay for a second. All right, there we go. We have just one notes, and we're putting them up into the typical upper left area. So let me put some glue on this. Come on, glue. Oh, too much. Tiny tabbles. There we go. And put it into its spot there. We got a good to know here. All right, press it. Good to know. Good to know on this one is talking about many algebraic expressions. Let's make sure I got that in frame here. Here we go. Many algebraic expressions have parentheses. We know that. We've been working with that. In order to simplify algebraic expressions with parentheses, we use the distributive property. Now, we multiply the front factor by each term in the parentheses. This is what we learned in 2.6, this part here. Okay? Now, algebraic expressions or equations often have like terms that can be combined. If there are parentheses involved in the expression, the distributive property must be used first before combining. So let's take our red pencil here and underline. The distributive property must be used first before combining like terms. Okay? And that'll seem pretty natural to you when we work out the problems. I don't think you're going to have any trouble with that. Okay, so I'm going to take my blue pencil and write a little note up in the top here. Here we go. So remember, a number next to a letter for example, 2x means multiply I wrote multiple, didn't I? Multiply, let's see if I can get that erased at all. All right, multiply Okay, a number next to a letter like that means multiply. For example, 2 times x. All right? That'll be important now when we're using the distributive property with variables. It'll look pretty much like what we did in 2.6. There's just some variables in there, and that make it look a little different. Usually it makes it so that we can't get to a final number for an answer because we have variables that we don't know their values of. So same process for the distributive property, and then combining like terms if we can. All right, so let's do two real simple ones first where we don't combine like terms. We're just using the distributive property with variables. All right. Okay, so my first step is to multiply 8 times x, right? Remember our rainbow from 2.6, right? Now, I don't know what x is, so 8 times x is 8x. It's still 8 times x, because I don't know what that is yet. I meant to write that in blue. 8x. All right? Then we bring down the operation, just like before. And then second step is 8 times 7, all right? 8 times 7 is 56, all right? Now, 8x and 5x, if we remember our combining like terms rules, those are not like terms. They would be like terms only if they had the same variables. The terms had the same variables. This term here has a variable of x, and this term here is a constant, what we call a constant. It doesn't have any variables with it at all, so they're not like terms. And so that's as simplified as we can go, all right? So we'll do another one very similar, all right? So we've got 3 times 2x plus 9. All right, so step 1 is 3 times 2x. Now 3 times 2 is 6, but don't drop that variable. It becomes 6x. All right, and then we bring down the operation. Second step is 3 times 9, which is 27. And again, 6x and 27 are not like terms. So that is as simplified as we can go. Nothing more we can do with those expressions. They do not have like terms. So I'm going to write under here, unlike terms, comma, fully simplified. Okay, unlike terms, fully simplified. We're not going to get to a one number answer here because we don't have values to plug in for those variables, right? And that's okay. They're just asking us to simplify, not solve, all right? If they wanted us to solve it, we would have to evaluate by plugging in some kind of a value they give us for the x. But we're not doing that. They're not asking us to do that yet. Okay? All right, so let's look at ones that are a little bit more complicated. So I'm going to move all the way over to the edge here with my number 3. And the problem is 8x plus 4 times x plus 1 plus 7. We got a lot more going on here. We're going to have to combine some like terms here for sure. All right, first, let's remember what we underlined here. You have to use the distributive property, take care of any parentheses before you can do any combining of like terms. Because you might think to yourself, oh, I have 2 like terms here, this 4 and this 7, so I'll add those together. No, and I can't take care of what's within this parentheses because I don't know what the value of x is. So I can't add x plus 1. I don't know what x is. So I have to take care of these parentheses first, remember PEMDAS, by using the distributive property. All right? So first step is 4 times x. All right? 4 times x is 4x. Bring down the operation, which is an addition here, and second step is 4 times 1, which is 4. Whoops. There we go, which is 4. Okay? Now, the next step is to bring down the rest of the expression. I've got this. There was an addition symbol here and an 8x. Now I'm back to way back what we did before with combining like terms. All right. So I have two like terms here. These both have x as a variable. And so I can add, there's an addition symbol here, 8 plus 4, which is 12. And that gives me 12x. And then remember how we learned I took care of those two, so now I'm going to cross them out. Then bring down the rest of the expression. I don't have any more terms in here that have a variable of 12. So I'm just going to bring down a variable of x, sorry. So I'm just going to bring down that 12x, and then I'm going to look, see, I have these two terms I can combine. They're both constants. They don't have any variables, so they are like terms. So I have an addition sign that needs to be brought down here, and then 4 plus 7 is 11. And so now I have 12x plus 11. 12x and 11 are not like terms, so that's as simplified as I can make it. All right? Okay, so let's do one more. I'm going to try and squeeze this in here a little bit. Okay, so 5 times, oh, I'm probably out of the frame a little bit. Here we go. 5 times x plus 4 plus 3x plus 3. Okay, distributive property first. So 5x, 5 times x is 5x. Bring down the operation, which is an addition. And second is 5 times 4 is 20. All right, we've taken care of the distributing, and so now we bring down the rest of the expression. All right, combining like terms, I got 5x plus 3x, so that is 5 plus 3 is 8x. You'd be surprised at how many people are going to put down 15x for that. Remember what we're actually doing. All right, plus, we have a plus. They're all additions in this one. I have two constants here of 20 plus 3. So that's 23. And that's my final answer there. 8x plus 23, because those are unlike terms, nothing more I can do. Okay? So I'm going to write a quick little note over here that says distribute then combine like terms. Okay, distribute, then combine like terms. That's what we're doing when simply distributing doesn't get us down to no like terms. Okay, so we didn't have to combine any like terms up here, nice and simple, but when they make them a little bit more complicated like down here, we have to do the distributing and then combine any like terms. Okay, all right, so that's the notes for lesson 2.7. Let's take a look at some practice problems. Okay, 2.7 practice problems. Very much like what we did in the notes. The first two are very simple. Just apply the distributive property. You don't even have to combine any like terms. Then we add a few more so that you apply the distributive property first and then combine like terms. And then I added a trickier one here we didn't do in our notes, but same thing applies. Apply the distributive property first and then combine like terms. And then you will see this on your worksheet, so I put this in your practice problems. Write and simplify an expression that would find the perimeter of this rectangle. Now there's more than one way we can do it. Remember, perimeter is what's happening out on the outside edge, not area in the middle. So we're just adding up all the sides. But what I want you to do, there's more than one way we could do it. We could add, but I want you to use the distributive property in your expression. So figure that out and then come back and see how I work these out. Let me get this for you here. And then these three. And then finally that one. Okay, let's see how we work these. Number 1, 3 times y is 3y. Bring down the operation, which is subtraction, and then 3 times 4 is 12. 3y and 12 are not like terms, so that's as far as we can simplify. All right. Number 2, 6 times m is 6m. Bring down the operation. 6 times 1 is 6. Watch this, because for some reason when 1 is at the end of the parentheses like this, students tend to want to put 1. 6 times 1 is not 1. 6 times 1 is 6. So watch that. 6 and 6m are not like terms, so that's as far as we can go. All right? Okay, now 3 and 4. We have to do the distributing first. So 2 times 3x is 6x. 2 times 3 is 6. Keep the variable. Bring down the operation, which is addition. 2 times 5 is 10. And then bring down the rest of the expression. There are no like terms for 6x. These are both constants with no variables. So I'm just going to bring down the 6x and combine these two like terms. 10 minus 7 is 3. And so 6x and 3 are not like terms. So that's as far as it can be simplified. All right, number 4. Distributing first. 4 times x is 4x. Bring down the operation, which is addition. 4 times 1 is 4. Okay. We've done the distributing, so now bring down the rest of the expression. And combine like terms. I have a 2x and a 4x. Those are like terms. There's an addition between them. So 2 plus 4 is 6, 6x. And I'll cross those out to remember I've taken care of those. Next, I have a 3 plus a 4, which is a 7. 6x and 7 are not like terms, so that's as far as I can simplify it. Okay? All right. Number 5. All right, number 5, I've got 2 distributing problems that I need to do. So 2 times m is 2m. Bring down the operation. 2 times 4 is 8. We've taken care of that distributing. Bring down this operation here and do the same thing on with this distributing. 6 times m is 6m. Bring down the operation. 6 times 3 is 18. And now I can combine like terms. I have a 2m and a 6m, so that's 8m. Cross those out, I took care of them. Plus 8 plus 18 is 26. 8m and 26, nothing more I can do with that. So that is my simplified answer there. All right? Okay, so the equation that we're going to write for this one is very similar to how it was written up here in number 5. Because remember, you could do x plus 2 plus x plus 2 plus 4x plus 1 plus 4x plus 1 and just combine all the like terms. But I want you to use the distributive property. There are 2 of these and 2 of these. So let's write it out that way. We should have 2 times 4x plus 1 plus 2 times x plus 2. All right? Very similar to number 5. All right, so 2 times 4x is 8x. Bring down the operation. 2 times 1 is 2. Bring down this operation connecting to the distributing. 2 times x is 2x. Bring down the operation. 2 times 2 is 4. Now I can combine like terms. 8x plus 2x is 10x. I've taken care of those two. 2 plus 4 is 6. So the perimeter is 10x plus 6. All right? That's how that works. All right. So your worksheet, let's take a look at that. Worksheet is very similar to everything we already did in your notes and your practices. These are the more simple ones. Use the distributive property. You'll need to use the distributive property on these first and then combine like terms. And then here are two perimeter problems. Just use the example that I gave you on the practice problem, and you'll do just fine with that. All right? Okay, so that leaves us then with our exit ticket. I do not give the answer to. It's just extra practice. Your teacher may use it in different ways. You may be able to ask your teacher for the answers. Okay, so that's lesson 2.7. Remember, the only way to learn math is to do math, and mistakes are proof that you're learning.